LED car headlamps have become the gold standard in modern vehicles. They are quickly becoming standard in all car models. You might not think too much about the lighting of your car, but we've come a very long way in how they operate, how you see on the road, and even what you see on the road. But what makes them so effective? And how do they compare to the halogen and HID systems they've largely replaced? Hi, I'm Samuel Locke with Auxito. Let's take a deep dive into how LED headlamps actually work and why they outperform older lighting technologies in nearly every category. At the core of every LED headlamp is a light-emitting diode, a solid-state semiconductor that produces a light through a process called electroluminescence. When electric current flows through the diode, electrons move through layers of semiconductor materials and recombine with tiny holes. That recombination releases energy in the form of protons, the fancy science word for light. This is very different from halogen bulbs of the past, which work by heating a tungsten filament until it glows, or HID systems, which use a high voltage arc between electrodes inside of a gas-filled quartz capsule. Both halogen and HID rely on heat and gas discharge to produce light, which leads to inefficiencies, warm-up times, and limited control. LEDs are far more precise. They're built from materials like gallium nitrate, which allow engineers to control both the intensity and color of light with extreme accuracy. Most white automotive LEDs use a blue LED chip coated with a yellow phosphor layer. When the blue light passes through the phosphor, it blends into a broad spectrum white that's ideal for nighttime visibility. And here's where the comparisons get interesting. Halogen bulbs, still common in older vehicles, typically emit about 15 to 20 lumens per watt. HID xenon lights improve on that with 35 to 7 lumens per watt, but LEDs easily outperform both, delivering 100 to 150 lumens per watt or more. That means LED systems produce more light with less energy, a crucial advantage when developing EV systems. The more ways we can save on that electric output, the more miles we can get out of your vehicle. But it's not just about brightness, it's also about control. LEDs emit light in a forward-facing arc, typically around 120 degrees. This makes it easier to shape and direct the beam using lenses and reflectors. Halogen and HID systems, on the other hand, emit light in all directions. That means more light gets lost or needs to be redirected, and often inefficiently. This makes for darker roads, less reaction time, and compromised safety. To manage this, LED headlamp systems use reflector-based designs, projector lenses, or hybrid systems that combine both. Reflectors can focus the LED's light onto a concentrated forward beam, while projectors use a lens and cutoff shield to shape a ultra-precise pattern, one that meets strict legal requirements for brightness and glare. Beam pattern is where LEDs truly shine. Halogen and HID lights often scatter, creating hot spots or blurry edges. These are typically found in high-end OEM headlight systems. LEDs may be arranged in matrix modules and work with camera sensors for intelligent dimming. These functions are typically found in luxury vehicles and aren't supported by standard halogen replacement LED bulbs. And here's something neither halogen nor HID can do, which is adaptive lighting. Thanks to onboard cameras and sensors, LED systems can detect traffic, curves, and elevation changes. The light beam dynamically reshapes, activating only the segments that improve visibility without causing glare. It's called adaptive driving beams, and it's one of the most advanced safety features in modern lighting. But powering LEDs is a bit different. Unlike halogen bulbs, which can be powered directly from a car's 12-volt system, LEDs require constant current drivers. These small current boards regulate voltage and prevent flicker, dimming, and overheating. Many systems also use pulse width modulation to finely control brightness without altering the light's color. Some vehicles with factory-installed low-frequency PMW signals may require LED bulbs with decoding capabilities, which we have here on the Auxito website. Another area where LED wins is in color temperature. Halogen bulbs emit a warm, yellowish light, typically around 3200 Kelvin, which is soft but not great for clarity. HID lights tend to hover around 4300 to 6000 Kelvin. LEDs offer even more range, often set between 5000 and 6500 Kelvin, closer to daylight. This bluish-white light improves contrast and helps drivers detect road markings, signs, and obstacles more clearly. There is a trade-off though. Higher color temperatures can cause more glare in fog, rain, or snow due to light scattering off the water droplets. This is why some premium systems use dual phosphor or tunable LEDs, adjusting the color temperature based on weather or driving mode. Thermal management is one of the biggest engineering challenges in LED headlamps. Despite the energy efficiency, LEDs still generate heat at the semiconductor junction. That heat must be pulled away fast to prevent brightness loss, or premature failure. LED modules include aluminum or copper heat sinks, thermal interfaces materials, and even sometimes micro cooling fans or heat pipes to dissipate heat. Halogen and HID systems also generate heat, but in those cases, heat is just a part of the light generation process. With LEDs, heat is an unwanted byproduct that must be managed aggressively to maintain efficiency and longevity. And that's another big difference. Lifespan. A typical halogen bulb lasts around 500 to 1,000 hours. HID stretches that to 2,000 to 5,000 hours, but LEDs can easily last 30 to 50,000 hours, often outlasting the car itself. That means fewer replacements, less maintenance, and lower total cost of ownership. So, what's the catch? LED systems can be more expensive to produce and repair. For sealed OEM LED headlamp unit, a failed LED chip may require replacing the entire assembly. However, standard retrofit LED bulbs are designed with plug-and-play connectors, making them individually replaceable and cost-effective to maintain. Additionally, retrofitting halogen housings with LED bulbs can also create glare or scatter, especially if the beam pattern isn't properly matched to the reflector. Despite these limitations, the benefits far outweigh the drawbacks. While the future of automotive LED is firmly LED driven and looking to boost your capabilities on the road, these future technologies like laser assisted headlamps and micro LED pixel arrays are currently being explored in luxury concept vehicles and are not yet available in the consumer grade LED bulb market. LED car headlamps represent the convergence of physics, electronics, software, and safety. Compared to halogen and HID, they offer better brightness, more precise beam control, far greater accuracy, longer lifespan, and more intelligence. That's our deep dive on the science of LEDs. Did you learn something new? Let us know in the comments down below. And if you're in the market for some shiny new LEDs, check out our shop in the links down below. I'm Sammy Locke with Auxito, and we'll see you next time.